Please welcome virtual speaker Dr. Anee Sieberhagen, Business Information Manager at Nampak R&D.
Good morning, colleagues, from a beautiful, chilly Cape Town this morning. I just want to get my presentation up and running here. Technology. Okay, first of all, before I proceed with this talk, I would just like to thank Safripol for this invitation to present at your sustainability conference. It's really an honor. So let's proceed. First of all, thank you all for participating in the poll. The question that we've posed was, the carbon emissions for glass bottles are significantly lower than those for PET bottles. So towards the end of the presentation, we will revisit the results. Okay, so I'll be talking to the carbon footprint of glass bottles versus plastic polyethylene bottles. So during this presentation, I would like to highlight the objectives of a study we undertook together with Safripol, the scope of the study, the approach of the study, and findings of the study to get an independent calculation of the carbon footprint of glass bottles versus those of PET. So, choosing between glass and PET bottles for beverages in terms of environmental impact is complicated. During 2019, October 2019, Nampak Richards, together with Safripol, wanted to obtain an understanding of the carbon footprint of glass versus PET. Why did we do that? At that stage, glass was seen as a major competitor for PET. We still had a glass manufacturing division, but also because of the seriously bad rap that plastic packaging and PET packaging gets in general. So we decided to commission a study, and we've used a consultancy firm to provide us with an independent calculation of the carbon footprint of glass and PET bottles. Why the independent calculation? Obviously, so that the public out there or our competitors perhaps won't say that we are biased towards our packaging. So therefore, very important to get an independent calculation and a firm to the study for you. So the scope of the study, we had to include a sample of bottles. So we selected the bottles based on their volume for comparison. Although the bottles have the same capacity, they are not necessarily interchangeable, as the intended use, option to refill or reuse is unique. So the bottles included during the scope of this study was let me just get my pointer here quickly. So the bottles included was a 1.5 liter glass bottle, wine bottle at that stage intended for wine, and the 1.5 liter returnable PET bottle. We also included the 500 ml glass bottle, as well as a 500 ml PET bottle. Important to note the weight of the bottles. As you can see, the weight for the 1.5 liter glass bottle was 760 grams versus 104 grams for the 1.5 liter PET bottle. Then the grammage for the 500 ml glass bottle is 299 grams versus that of 21 grams for the 500 ml PET bottle. This is important because the CO2 emissions was calculated per bottle based on its weight. So for the scope of the study, we focused on a cradle-to-gate life cycle assessment. So on the next slide, we'll unpack the cradle-to-gate life cycle assessment, but it focuses generally on the inputs, the transportation, the manufacturing process, warehousing, consumption, such as the bottling company and by the consumer, and its end of life were not taken into consideration. Okay, as mentioned, the study comprised a cradle-to-gate life cycle assessment of the selected bottles shown in the previous slide. So cradle-to-gate is a partial product life cycle from the raw material extraction, which is now your cradle, to the factory gate, before it's transported to the consumer. The use phase in this image here and the disposal phase of the product are omitted in this case. So the raw material would typically be your feldspar, your lime, your cullet used for the PET bottle, the glass bottle, sorry, apologies, and then the virgin PET or the recycled PET used to manufacture the bottle. In this study, we did, however, include the transport to the warehouse and the wholesale customer, not the bottling plant, for filling. So it was transported from the manufacturing site, so our plastics division and our glass division, to the warehouse. So we've also followed the following approach. We had to document the manufacturing process, and for that we used a CPOC methodology. This methodology was aligned to the cradle-to-gate life cycle assessment that we undertook. So what is a CPOC? CPOC is where we had a look at the suppliers, which will also be unpacked a bit further, the inputs, the process of manufacturing the bottle, the outputs, which will be your 1.5 liter glass bottle, your PET bottle, your 500 ml glass bottle, and your 500 ml PET bottle. And as mentioned, this was aligned with the cradle to gate, so the consumer part of the process was not included in the study. So just to unpack what the CPOC for glass would look like, the inputs would be the extraction of the raw materials, the sand, soda ash, lime, feldspar, chemicals, the cullet, which is the recycled glass that gets mixed to get your flint glass. This extraction also included from the suppliers like Idwala glass, Safripol, PET, or wherever it might come from. And it would include another input, which is your capital infrastructure, your direct overheads, your indirect overheads. Following that, it would be the actual conversion, the process to manufacture your bottle. So it would be the melt, the blow molding, the quality assurance to cool down, and you'll get your finished product. So it would be your 1.5 liter and your 500 ml glass. From there, it would get packaged either in a box, put on a pallet and wrapped, and it would go into storage and distribution. As mentioned, we have not included the bottling part where it's at the beverage manufacturer where it's supposed to be filled, closed, and labeled. Excluded also going to the retailer, the consumer. End of life, post-consumer also not taken consideration because it's a cradle to gate. So what would the CPOC look like for a PET and the returnable PET bottle? Again, the extraction of the raw materials, your virgin PET, your recycled PET, any chemicals that goes with that. Again, we would concentrate on the capital infrastructure, the direct overheads, indirect overheads, and then the whole conversion process of drying, melting, inject to preform, blow molding, cool down. Your finished product, again, that would get palletized, packed into boxes or on pallets, wrapped, and then go into storage and distribution. Again, the beverage manufacturer, the filling part, the consumer part, the end of life, either being waste managed by collection, sorting, cleaning, going to landfill, or being recycled was not included because it needs to be aligned with the life cycle assessment cradle to gate. So the approach, how did we get all these information and documentation to compile the CPOC? First of all, a bit of brainstorming, review existing process information with, for instance, the engineers. Interviews, we physically visited plants, head office, the glass plant, the PET plant. Desktop research were also conducted, but very important was to get the data to actually do the calculations. So we made use of NAMPAC's enterprise resource planning platform called JD Edwards, various financial records, production volumes from the plants, energy usage, wastage rates, water usage, input from our suppliers, for instance, they also kind of their CPOC on where they get the raw materials, how it gets transported to our plant. Would it be via rail, boat, plane, or road, as is the case mostly in South Africa? And then also, as I've mentioned, how it would get transported either to our manufacturing plants, but also then to the warehouse. This part proven to be the most difficult one. And we had to use a wide variety of resources within NAMPAC, from your financial directors to IT, your plant production, people on the line that had the production volumes. We had to get the energy usage from the engineers and wastage rates, etc. from for instance, your operational directors or the operational managers were also very important here. So once we compiled the CPOC, in each element of the CPOC, a cost and a carbon footprint was calculated or assigned. So just to refresh your memories quickly. So for each of these elements, we had to assign a carbon footprint as well as a cost. So the cost consisted of a bill of materials, which are the cost of your raw materials. Obviously, this is sensitive and confidential information, so unfortunately, I cannot share that with you. And then also the manufacturing cost and the overheads to manufacture your PET bottle or your glass bottle. Then to calculate or to assign a carbon footprint, we calculated them using the guidelines of the GHG protocol for the carbon emissions, GHG, Global House Gas Protocol. We used scope 1, 2, and 3. Scope 1 are direct emissions, for example, your combustion or controlled boilers, your furnaces, your vehicles. Scope 2 is your energy direct. So these are the emissions generated by purchased electricity by the company. And then also we use scope 3, which is an optional reporting category that allows for the treatment and extraction and production of the purchased materials. Remember, I've mentioned that we also spoke to the suppliers of the raw materials, like your feldspar, your lime, soda ash that goes into the glass. So the activities included in the extraction, production, and so on, and the transportation was also included. Once all this was done, we could do the necessary calculations and assign the costs. And from there, we could arrive to the following CO2 emissions for which were calculated per bottle. So for the 1.5 liter glass bottle, the CO2 emissions calculated for this bottle was 853. For the 1.5 liter returnable PET, it was 427. For the 500 ml glass, 335, and 85.11 for the 500 ml. So from this, we can already conclude that the carbon emission for the PET 500 ml bottle is significantly lower than that one for the 500 ml glass bottle, and the same goes for the 1.5 liter. So, findings. The carbon emissions and manufacturing costs. It is 7% more cost effective to manufacture a 1.5 liter PET bottle to be used in this instance for carbonated soft drinks than the same size glass bottle that is used for wine. This one is refilled, not refilled. The carbon emissions to manufacture a 1.5 liter returnable PET bottle, is 50% less, has 50% less carbon emissions than that to manufacture a 1.5 liter glass bottle. Also important to note is that the returnable bottle has an assumed useful life of about 11 refills, cumulatively saving 67% of the cost to manufacture a new returnable PET bottle over its lifetime. If we look at the 500 ml bottle, it was 64% more cost effective to manufacture a 500 ml PET bottle compared to the same size bottle in glass. The carbon emissions is 78% less for a PET bottle. So the process emits 78% less CO2 during conversion. Interesting to note here is that this bottle was made with 40% recycled glass, whilst the PET products reviewed were made from virgin materials, both imported, this one, and sourced locally, this one, the 500 ml glass. So in conclusion, the study found that it is more cost effective to manufacture a 1.5 liter returnable PET bottle or a 500 ml PET bottle than the same size bottle in glass. The carbon emissions to manufacture returnable PET or PET was calculated to be significantly less than that of glass. If we revisit your poll quickly, unfortunately, I don't have it with me because this is now live recording. But in general, most people voted correctly that the answer is actually false. PET bottles, the carbon emissions for PET bottles are significantly lower than that for glass bottles. Thank you very much for your time.